Now coming to group data. Until now we've been seeing data which is scattered and they're just separated by commas. But here we are actually grouping the data and we're looking them together as a group. So there are two ways in which you can group data that are of certain importance to us, and that is this discrete frequency distribution and continuous frequency distribution. So we'll be discussing continuous frequency distribution in the next module, and right now we are looking at discrete frequency distribution. So how it's seen is, you have a particular quantity and you have its frequency. You have a quantity, you have its frequency, right? So frequency is discrete. It's for discrete quantities. And here you will see something like a 20 to 30 and this much frequency, some 10 frequencies, some 30 to 40 and some 20 frequencies. You'll have a group of data. You'll already have a range of data for which the frequency will be given. And here you have discrete data for which frequency is given. So that's why this is frequency distribution. But nevertheless, it is still group data. Why? Because we are grouping all the ones together and we are calling it with frequency 9. You're grouping all the 2's together and you're associating them with frequency 6, right? That's what you're doing. This is group data only. So let's look at how to find the mean of this. The formula that we use is sigma fi xi by sigma fi. So what you do is you multiply x with the frequency, and you do that for each other. So 1 into 9, 9, plus 2 into 6, 12, plus 3 into 4, 12, plus 4 into 10, 40, plus 5 into 12, 60, plus 6 into 7, 42, and then you have 7 into 8, that is 56, and then you have 8 into 13, which is 112, right? Yeah. So I beg your pardon. 8 into 13 is not 112, it's 104. So 104 plus 126 is what you have, right? This 9 into 14 is 126. This divided by summation of the frequencies. So when you sum up all these frequencies, what you finally get is 83, right? You get 83. So when you carry out this division, finally, when you write the sum here, what you get is 461, and that divided by 83, which is something like 5.55. So this is the mean of this data. It's an interesting thing. How do you find median? To find the median of this, what we do is we construct a cumulative frequency column here. The cumulative frequency is writing the first frequency as it is. Then to this frequency, you'll add the next frequency, 9 plus 6 is 15. To this frequency, you'll add the next frequency, 15 plus 9, 15 plus 4 is 19. Likewise, to 19, you'll add 10, that's 29, and you'll keep doing this for all of them. So 41 plus 7 is again 48, 56, 69, and then 83. So 83 is basically your final answer. This is basically denoted by n, by capital N, right? Remember, small n is denoted by number of elements. Number of elements is denoted by small n, which we saw in the previous case, where we did sigma x minus si by n, and many other cases, sigma xi by n, where we calculated mean. There is that small n meant number of elements. Here capital N, whenever I write capital N, that means cumulative frequency, like final cumulative frequency, or rather the sum of frequencies, sum of all frequencies, and that's 83 here, right? How do you find median? So basically what you do is, the method is where you divide this n by 2, and when you divide your n by 2, what you get is 41.5, right? 83 by 2, and that's 41.5. Now if you can see, in all these quantities, in all these cumulative frequencies, the value which is greater than or equal to 41.5 is what you choose, and that's 48, right? 48 is the value which is closest to 41.5 and greater than it. So 41.5 will lie somewhere here. You're not supposed to take anything below it, you're supposed to take the one above it and closest to it, that's 48. The number that's corresponding to 48 is 6, so your median is 6. That's the method. I hope you were able to figure that out. Mode is very, very simple for this, because mode is just about, what is the definition for mode? The number which occurs maximum number of times, right? So here 1 is occurring 9 times, 2 is occurring 6 times. So how do you get the mode? The one which has the greatest f, that is the mode, right? Because as you can see here, this particular quantity 8, it's or this particular quantity 9, it's occurring 14 times. There is no quantity which is occurring as many times as 9, right? And so 1 is occurring 9 times, 2 is occurring 6 times, and 9 is occurring 14 times. There's nothing which occurs greater than 14 times. So your mode is simply 9. That's how you just observe the value and write the mode. That's all about your discrete frequency distribution, mean, median, mode. Let's look at the measures of dispersion for discrete frequency distribution. So let us now look at the measures of dispersion for discrete frequency distribution. So I'll be giving you the formulas and the methods, but this example is just taken for me to actually tell you how to actually interpret data from the table and use them in these formulas. But I won't be giving you the final answer. I'll be leaving that to you. So we have these three measures of dispersion. We don't have a range for this particular thing. What we are interested in are these three: mean deviation with respect to mean deviation with respect to median, and then finally your variance and your standard deviation. So these are the formulas. Let me show you this particular thing because once you understand this and this, you can just plug in values from the formula and carry out the calculations yourself. So what is sigma fi into xi minus x bar? So this is your x, your quantities, your data points, and this is f, the frequency. So every x is called an xi and its corresponding fi exists, right? So for 1 the fi is 9, for 2 the fi is 6, something like that. Now we've already calculated the mean for this particular distribution, this xf distribution already, that was 5.55 in the previous case. After that, what you have to do is basically make the table of xi minus x bar. What is xi? Basically xi minus x bar will tell you how far each data point is from its mean. So for example, your mean is 5.55 somewhere here, and this data point 1 is here. So 1 minus 5 basically is minus 4.55. When it came to ungrouped data, there we took mod of xi minus x bar, but here we don't take a mod. Here we take it as it is. That's why I made a table of xi minus x bar. So you have a minus 4.55 here, which is 1 minus 5.55, which is minus 4.55 here. Likewise, every quantity I've plugged in this formula. So for example, here you have a 3 minus 5.55, 3 minus 5.55 is minus 2.55, and I put that here. Likewise, I put all the values here for xi minus x bar, right? Then what you need to do is you need f into xi minus x bar, because the formula is like that. So 9 into this quantity, which is minus 40.95. 6 into this quantity, which is minus 21.3. Likewise, frequency into xi minus x bar, minus 10.2. Likewise, 8 into 2.55, this particular quantity. So you need to make a table of xi minus x bar. Then you need to add all these fi into xi minus x bars, all of these, right? Because it is sigma fi into xi minus x bar. So you add all of them up. Finally, what you get is 46.55. This 46.55 you divide with capital N. What is capital N? The total frequency, the sum of all frequencies. So basically, the mean deviation for this data is 46.55 divided by 83. Now whatever that is, you can calculate. Similarly, mean deviation, what do? Instead of this x bar, you take the median, which is already 6. We have calculated this in the previous module. M is equal to 6. So basically, you subtract 1 from 6, you will get a minus 5. You subtract 2 from 6, you will get a minus 4. So you make a table of xi minus m here. Instead of xi minus x bar, you make a table of xi minus m. Then you make a table of fi into xi minus m. So for example, for the first data point, 1 minus 6, basically minus 5 was your xi minus m, and that should be multiplied with the frequency. So minus 9 into 5 is minus 45. So fi into xi minus m, when you make the first quantity here will be minus 45. Likewise, you make a table completely for all the data points, add them up and divide them with the total number of frequencies, some of the frequencies, and that will give you the required answer. Coming to variance. For variance, we use this formula, 1 by n to fi into xi minus x bar whole square. Now once again, I've not made a table of this, but you have to make it yourself. This particular quantity that you see here, xi minus x, you need to make a square column. So if you have minus 4.55, you need to square that. If you have minus 3.55, you need to square that. So you need to make a table of
the squares of all the quantities, right? You need to make a table of squares of all the quantities. That will give you your xi minus x bar whole square. And then this quantity you need to multiply with the frequency. So the first frequency is 9, so this you'll multiply with 9. The second frequency is 6, you'll multiply with 6. Then you'll finally get a table of fi into xi minus x bar whole square, right? You'll add those values up, you'll take the final thing from the bottom and divide that with capital N, that is your 83, right? So that will give you the answer for variance. And when you take the square root of the variance, because variance is sigma square, standard deviation is sigma. When you take the square root of the value that you get from variance, you get standard deviation, right? So these formulas are important, and you can actually practice problems on your own anyways, because you'll have them in your textbook anyways. There's not a lot of concept involved here, just picking up the formula and applying the formula in the required scenario. So for example, if you're talking about discrete frequency distribution, you should first be able to recognize that, okay, this is a discrete frequency distribution. So you need to pick up formulas from discrete frequency distribution section and use that to calculate what's required in the question, right? So you can do that yourself. Let's now move on to continuous frequency distribution.